Hello, hello everyone. Today we are going to solve May-June 2019 2-1 paper. It's theory paper, it's paper 2 of the Physics 5054. Okay, and today in this video we will be solving on only the section A. On your screen, question number 1. Figure 1.1 shows the distance time graph for a journey made by a cyclist between town A and town B. So you can see here we have a distance time graph on the y-axis. Distance is represented, on the x-axis time is represented. On the x-axis the time is given in hours, and with the 10 small squares he has shown 1 hour. So one small square is representing 6 minutes. On the y-axis, distance is given in kilometers. The cyclist leaves town A at the time equals to 0 and arrives at town B at the time equals to 4 hours. Question number A, part 1, determine the distance between the two towns. This question is very simple. You see, at the point O, he was in town A, it was here, and at 4 hours, he was here, it is town B. So how much is this distance? So from 50 to 60 there are 5 squares. So each square is representing 2 kilometer. So you are 1 square below the 60. So your distance between A and B is 58 kilometer. It's a one number mark, one number question, and you have to answer from the graph. So 58 kilometer is the answer. Second part of question number A is determine the time for which the cyclist rests during the journey before he reaches the town B. Okay, so at 4 hour he was in the town B. At 0 hour he was in town A. So during this journey he rested. On the distance time graph, the rest is shown when the distance time graph becomes flat. So it was flat during this portion. If you can see on the graph paper, let me increase its size so it's very clear to you, because we have to answer it. Okay, now it's good. Now, from this, during this portion, during this time, he was at rest. So count how many squares are there. 1, 2, horizontally. 1, 2, 3, 4, 5, 6, 7, 8. So 8 squares. For 8 squares, the graph is horizontal. Each square is representing 6 minutes. So multiply 6 with 8, you get 48 minutes. Because each square represents 8 minutes, so there are 8 squares, so 6 multiply 8, and the answer will be 48 minutes. So its answer is 48 minutes. The next B part is the speed of the cyclist near the end of the journey is greater than the speed at the beginning. State how the graph shows this. Okay, look at here. The portion of the graph here and the portion of the graph here. This second portion looks more steeper, or its gradient is larger. The gradient of the distance time graph represents speed. So because in this portion the graph is steeper as compared to the slope of the graph here, and the slope of the graph represents the speed here, so it means here the cyclist was faster. Then the C part is calculate the average speed for the cyclist for the journey from A to B. Calculate the average speed of the cyclist for the journey from A to B. So during this time period from 0 to 4 hour, he wants us to find out what is the average speed. Average speed is total distance traveled divided by total time taken. So we know from A to B the distance was 58 kilometer. You divide it with the time taken. The time taken is 4 hours. So if you divide 58 with the 4 hours, you will get the answer. I have done this on a, you can see on your screen, we have question number 1 is on your screen. Can you see it clearly? Let me increase its size. Yeah, I hope it's clear now. Yeah. So average speed is total distance by total time. Total distance is 58 kilometer divided by total time is 4 hours. So the answer will be 14.5 kilometer per hour, which is approximately 15 kilometer per hour. So this is how we will solve question number 1. I hope it's clear to you. Let's move to the next question. So question number 2 is on your screen. Okay. You can see question number 2 is on your screen. A part, some sources of energy used to produce electricity may run out in the future. Underlying two sources of energy that are likely to run out first before the others. So, the energy sources are of two kinds. Um, Renewable energy sources and non-renewable energy sources. So he is basically asking you to underline non-renewable energy sources, which will run out as the time will pass by. So they are first two, coal and oil, they are the very famous example of the non-renewable energy source. So underline coal and oil. Okay, question number 2B part. Figure 2.1 is a simplified diagram of a geothermal power station. Thermal energy is given to the water as it passes through rocks underground. Describe the process by which this thermal energy causes the turbine to turn. It's very simple. You see, here we have a shaft, and through that shaft, cool water goes underground. And underground, it will absorb the geothermal energy. The temperature of the water will rise, and the water will turn into steam, and that steam will be at very high pressure. And that steam under very high pressure comes out from here. When that steam at very high pressure comes here, it hit the blades of the turbine, and the turbine starts turning or rotating. And this is the question he wants you to describe this process. I have done this on a paper. Let me take it out. Okay. Question number 2 is on your screen. I hope you can see clearly. Question number 2. Okay. B first part. Water injected into ground absorbs geothermal energy and is converted into steam. Steam is at very high pressure. High pressure steam apply force on turbine, and this force turns the turbine. It's a 2-number question. I hope I have made my point clear. Okay, we are moving to the next part of this question. It's a numerical. He says, water from the cooling tower at 30 degrees centigrade passes into the ground and is heated to 160 degrees centigrade. The specific heat capacity of water is 4200 joules per kg per degree centigrade. Calculate the thermal energy needed to heat 90 kg of water from 30 degrees centigrade to 160 degrees centigrade. Now, it's a straightforward numerical. In this, the specific heat capacity of the water is given. The change in the temperature, the initial and the final temperature is given, so we can find very easily the change in the temperature. The initial temperature is 30 degrees centigrade, the final temperature is 160 degrees centigrade, so you can find the change in temperature. And the mass of the water is also given. He wants us to calculate how much energy will be needed. When the change in temperature takes place, we can calculate the amount of heat needed by the formula heat is equals to mc delta theta, where m stands for the mass of the water, c stands for the specific heat capacity of the water, and delta theta means the change in the temperature. It's a 2-mark numerical. I have solved it on your screen. I hope you can see. Heat is equal to mc delta theta. M is 90 kg. C specific heat capacity is 4200 joules per kg per degree centigrade. And change in temperature will be 160 minus 30. The change in temperature will be 130. So multiply them, the answer will be 4.9 x per 7 joules. I hope you have understood this numerical. Okay, we are moving to the next question. Next question on your screen is question number 3. A large spring is stretched by an athlete to increase the strength of his arms. The athlete extends the spring as shown in figure 3.1 and then releases it gently. He extends and releases the spring several times during a period of 60 seconds. State the form of energy stored in the stretched spring and the form of energy stored in the muscle of the athlete. The form of energy which is stored in the spring when you stretch it, that form of energy is called elastic potential energy. He says form of energy in the muscle. The form of energy in the human muscle is called chemical potential energy. In the B part, he says, so just what happens if he extends the spring beyond the limit of proportionality? If you stretch the spring beyond the limit of proportionality of that spring, the extension and the load which you apply to the spring, or the force you apply to the spring, they will be no more directly proportional to each other. After crossing the limit of proportionality, it becomes easier for the spring to stretch. I have written this answer also. We can take help from there also. See on your screen, the A and the B part is showing for question number 3. Elastic potential energy, chemical potential, that is for the A part. B part, if spring is stretched beyond the limit of proportionality, extension will be no more proportional to load, and extension will become easier. C part, during one extension of the spring, its length increases from 70 centimeter to 93 centimeter. The average force exerted by the athlete is 400 Newton. Calculate the work done by the athlete in one extension. So spring is normally 70 centimeter. And when you apply force, due to that force, the spring becomes of 93 centimeter. So the length of the spring changes from 70 centimeter to 93 centimeter. So under the influence of that force, the spring has moved how much? 93 minus 70. That will be 23 centimeter. So if you want to find out how much work is done, that is force into distance. You applied a force of 400 Newton and it moved the spring for 23 centimeter. You multiply them, you get the work done. But you see, in the formula of the work done, the distance must be taken in the meters. To convert the 23 centimeter into meters, you have to divide it with 100. Because let me show you the working. Okay. I hope that C first part is on your screen. Distance is 93 centimeter minus 70 centimeter, so it will be 23 centimeter. If you want to convert 23 centimeter into meters, divided with 100. So the answer will be 0.23 meter. So I have converted the unit from centimeter to meter. The force you applied is 400 Newton. The work done is equals to force into distance, 400 into 0.23. The answer will be 92 joules. So it's a two-number numerical. It's not that difficult. It's easy. Okay, we are moving to the next part. It's the question number 3, and it's C and its second part. Describe how the athlete can use the value obtained in the first part to determine his average power during the 60 seconds. So the question is how we can determine the power of the athlete which he creates in 60 seconds. So I know till now, I know in the first portion, in the first part of the C, I know one thing, that when he do one extension, how much work is done. We just calculated this. So if you want to calculate how much power is created or generated by the athlete in 60 seconds, so first thing you should know is how many times he extend the spring in 60 seconds. So you have to count that in 60 seconds, how many times he extends the spring. And I know the work done in one extension of the spring. So if you know the number of times he extends the spring in 60 seconds, you multiply that number with the work done in one extension. And then divide it with the 60 seconds. So if you know in 60 seconds how much work is done, then divide it with the time, because the power is work done divided by time. So you calculate how much work is done in 60 seconds by that athlete and divide it with 60, you get the answer in watts. I have written this answer also on paper. So let me show you that. So on your screen, you can see C second part. He counts how many times he extends the spring in 60 seconds. He will multiply 92 joules with number of extensions and divide with 60 seconds to get power in the watts, because power formula is total work done divided by time. And the unit of the power is watt. So it's a two-number question, not that difficult. I hope the question number 3 is clear to you. Let's move to the next question. The next question on your screen, question number 4, figure 4.1 shows a cylinder with a piston that contains a gas. A liquid occupies a much smaller volume than a gas, which has the same number of molecules. Explain why there is this difference. You know, if the gas and the liquid, they both have the same number of molecules, the liquid will occupy less volume. The reason is the liquid has stronger intermolecular forces between its molecules as compared to the intermolecular forces of the gas. Another reason is that the intermolecular spacing between the molecules of a liquid are smaller as compared to the intermolecular spacing between the molecules of gas. So that's why the liquid will occupy less volume. I have I have noted its answer on a paper. Let me show you. Okay, I hope this is on your screen showing. Let me increase the size. Question number 4. Question number 4A part. Intermolecular forces between molecules of liquid are stronger than molecules of gas. Intermolecular spacing between liquid molecules is smaller than gas molecules. So these are the two reasons due to which the liquid occupies less volume as compared to gas, if the number of molecules of gas and the liquid are equal to each other. Okay, B part. The volume of the gas changes from V1 to V2 as the piston moves into the cylinder. This increases the pressure from P1 to P2. The temperature remains the same. So there are two things very important, that he's talking about gas. He's changing volume, the pressure is changing. The second most important thing is that the temperature remains the same. The first part, he asks you a question, state the formula that relates V1, V2, P1, P2. Underline that temperature remains the same. The formula which relates, if the temperature remains constant, the formula which relates the volume and the pressure is P1 V1 equals to P2 V2. P1 V1 equals to P2 V2. B, second part. The initial pressure of the gas in the cylinder is 1.2 expo 5 Pascal. And its initial volume is 100 centimeter cube. The cross-sectional area of the piston is 5 centimeters square. The piston is pushed in a distance of 8 centimeter. Calculate the final pressure of the gas in the cylinder. Okay, so he's talking about this piston. Let me reduce the size so I can show you the figure and all things together. Okay, so he is talking about this gas which is in the cylinder, and this is the piston. So he says right now in this condition, the volume 1 was 100 centimeter cube and the pressure 1 was 1.2 expo 5 Pascal. Then what happened? The piston moved to the right. The piston moved into the cylinder. How much? 8 centimeter. So the piston moved towards the right 8 centimeter. So the question is, what will be the new volume of the gas? When the piston will move to the right, the new volume will be less volume as compared to the V1. But what will be that? You know, he gave us the cross-sectional area of the piston and the cylinder, 5 centimeters square. And he gave me how much distance the piston moved, 8 centimeters. If you multiply the cross-sectional area with the length, you will get the volume. If the cross-sectional area is 5 and the distance moved is 8, multiply them. 5 into 8, it will be 40 centimeter cube. Before, the volume was 100 centimeter cube. And because the piston moved 8 centimeter, now there will be a decrease of volume of 40. So the remaining volume of the gas will be 100 minus 40, and it will be 60 centimeter cube. So the V2 is 60 centimeter cube. So this is the most tricky portion of the question, to calculate what is V2. Once you know the V2, then the question is very simple. Apply the formula P1 V1 equals to P2 V2. The P1 value is 1.2 expo 5. V1 value is 100 centimeter cube. P2 value is question. And V2 value is 60. Do the calculation and you will get the P2 value. It's a 3-number numerical. Let me show you my working. I have done working on it. Let me show you that work. It's a 3-number numerical. So here we have done this. So change in the volume is cross-sectional area 5 multiply 8 equals to 40 centimeter cube. So the remaining gas has a volume, before it was 100 centimeter cube and 40 centimeter cube has reduced. So the new volume will be 60 centimeter cube. Apply the formula P1 V1 equals to P2 V2. P1 value, V1 value equals to P2. We want to find out. V2 is 60. So if I will make P2 alone and this 60 will go on the other side, it will divide, do the calculation, and the final answer will be 2 expo 5 Pascal. It's a 3-number, 3 marks numerical. So it's important. And the trickiest part was where you calculated V2. The rest of the thing was easy. So I hope this numerical is clear to you. Okay, Ji, we are moving to the next part. This is the B and its third part. Question number 4B and its third part. On your screen, I hope you can see. Let me reduce the size. Yeah. Explain using ideas about molecules why the pressure of the gas changes. When you move the piston to the right, the volume of the gas decreases. When the volume of the gas decreases, what happens? The number of collisions per second, we call it collision frequency. The collision frequency of the gas molecules with the walls of the container increases. Due to this increase in the collision frequency, the pressure increases. We also use another sentence that the number of molecules per unit volume also increases, and this increases the collision frequency, and thus the pressure of the gas increases. I have written this answer also. Let me show you that answer. Yeah, question number 4C, third part. When volume of gas decreases, collision frequency with walls of cylinder increases. This causes pressure of the gas to increase. This is a one number question, so this one reason is enough. Okay, so this was question number 4. I hope that I have made it very clear. Okay, Ji. On your screen we have question number 5. A student uses the circuit shown in figure 5.1 to investigate a resistor R. He's trying to find out the resistance of this resistor. So he had connected parallel to it a voltmeter and an ammeter in series with it. He has connected a battery, DC battery, and he also connected here a variable resistor. Describe how the student uses the apparatus in figure 5.1 to obtain a range of ammeter and voltmeter reading. So it's very simple. Because he has connected here a variable resistor, so what he can do, he make the resistance of the variable resistor maximum, and he connect the battery and note what is the reading on the voltmeter and the ammeter. Then he reduces the resistance of the variable resistor a little and note what is the reading on the voltmeter and the ammeter. Then he reduces the variable resistor's resistance further and notes what is the value on what is the reading on the voltmeter and the ammeter. You see, by changing the value of the resistance of the variable resistor, he is able to find different values or different readings on the different set of readings of the voltmeter and the ammeter. So this is how. This is a 1 mark question. Let me show you. I have also written its answer. Question number 5A part. Change the resistance of variable resistor and note values of current and voltage from ammeter and voltmeter. So keep on changing the value of the variable resistor and you will get different set of values of the readings on the voltmeter and the ammeter. Okay, so question number 5B part. He says the readings obtained are shown in the table 5.1. So he has, when on the voltmeter the reading was 7.6, the reading on the, let me increase the size. Yeah. When the reading on the voltmeter was 7.6, the reading on the ammeter was 320 milliampere. When the reading on the voltmeter was 5.2 volt, the reading on the ammeter was 220 milliamp. When the reading on the voltmeter was 2.4 volt, the reading on the ammeter was 100 milliamps. The first question he's asking you to answer is state Ohm's law. So it's a statement. It is the statement of the law. So it's very simple. He says that Ohm's law states that the potential drop across a resistor is directly proportional to the current flowing through the resistor, provided that the physical condition of the resistor do not change. Especially the temperature of the resistor should not change, and the resistance of the resistor should not change. I have written this answer also. Let me show you that. Uh, B part, yeah, B first part, the statement of the Ohm's law. It says voltage drop across a resistor is directly proportional to current flowing through resistor if physical conditions of resistor remain constant. Okay, so the next part, using the result in table 5.1, show that the resistors obey Ohm's law. If they are obeying Ohm's law, I got different values of the voltmeter and different corresponding values of the ammeter. If this resistor is obeying Ohm's law, if I will calculate the value of resistance for each of these set of values, the resistance value will be approximately same. So we can do this calculation. You know, resistance is equals to V divided by I. So for each value here, do that calculation. For example, I will do 7.6 volt divided by 320 expo minus 3 amp and get the answer. 5.2 volt divided by 220 expo minus 3 amp, get the answer. 2.4 divided by 100 expo minus 3 amps and get the answer. This will give you R1, R2, R3. You will observe that the R1, R2, R3 values are approximately equal to each other. If this results come out, R1, R2, R3 values are approximately same, this means that the value of the voltage is changing, the value of current is changing, but the resistance value is constant. In other words, if I talk it technically, the ratio of the voltage and the current is constant. What is resistance? It is the ratio of the voltage and the current. V divided by I, ratio of the voltage and the current. If that value is constant, it means it's obeying Ohm's law. Either you say the ratio of the voltage to current is constant, or you say resistance is constant. I have shown, I have done this this on a paper also. On your screen, you can see B second part. I just calculated R1. I got 24 ohm. It was 23.75 ohm, approximately 24 ohm. R2, it was 23.64 ohm. It's approximately again 24 ohm. And R3, it was exactly 24 ohm. So the value of the resistance is 24 ohm. So you see the resistance is not changing. So you see the ratio of the voltage to current is constant. If the ratio of voltage to current is constant, it means voltage and the current are directly proportional to each other. It means it is obeying the Ohm's law. I hope it's clear. Okay, so we move to the next part. Okay. Question number is third part is the student has available an ammeter with 5 ranges marked 0 to 10 ampere, 0 to 200 milliampere, 0 to 20 milliampere, 0 to 2 milliamp, and 0 to 0.2 milliamps. These are the, he got some kind of multimeter, so he has ranges for the ammeter. So that's how the student make best use of the different ranges during this investigation. Okay. So you see what is the amount of current? You have 320 milliamp, 220 milliamp, and 100 milliamp. Remember these numbers: 320, 220, and 100. Okay. For 320, I need to use this range 0 to 10 ampere. For 220, we still need to use this. And for 100 milliampere, you can use this range 0 to 200 milliamps. I have written its answer. You can see that For 320 milliamps and 220 milliamps, set the range to 0 to 10 ampere because the rest of the ranges are less than 220. For 100 milliamps, set the range to 0 to 2 milliamps. This is a 1 mark question. I hope that question number 5 is clear. It's very clear to you. Okay, so we are moving to next question. Question number 6. On your screen, question number 6. Figure 1.1 shows the fuse inside the plug of a hair dryer. State how the fuse protect the wire in the hair dryer. You see here in this fuse, you see this thin wire. Yeah, this thin wire. Okay. You see, every fuse has a rating. Every fuse has a rating. It's amount of current which it can bear. If the amount of current flowing through the fuse exceeds its rating, so due to the heating effect of current flowing through this thin wire, that heat becomes so excessive that this thin wire melts. When this thin wire melts, this wire breaks, the circuit is broken, and the supply of the live current to the hair dryer is cut off. So if the current exceeds the certain limit, the fuse will blow and it will protect your hair dryer from burning or damage. I have written this answer also. Question number 6A part. If current flowing through fuse exceeds its rating due to heat produced, thin wire in the fuse will melt and break. This cut off the supply of live current to the appliance. So your appliance will be safe. Okay. So let's move. I hope this is clear. This was 1 mark question, not that difficult. Question number 6B part on your screen. The hair dryer is rated 240 volt, 1500 watt. It is switched on. Calculate the current in the hair dryer. For electric power, you remember the formula is power equals to IV. Famous formula. Power is equals to IV. So 3 things are involved: power, voltage, and current. The power and the voltage value is given, and the current is questioned. So I will be equals to P divided by V. I have done this numerical. Let me show you that working. Okay. On your screen, B's first part, can you see that? P is equals to IV. Power is 1500 watt and the voltage is 240 volt. And I, if I make the I alone subject of the formula, this 240 will go on the other side. Divide, do the calculation. The answer will be 6.24 amp. 6.24 amp. It's a 2 marks numerical. Easy. It's very easy. Okay. So the next question, suggest a suitable current rating for the fuse. The amount of current which will be flowing through the amount of current which the hair dryer will need is 6.24 amp. 6.24 amp will be the current needed by the hair dryer. So the fuse you put there should be of the rating more than 6.25 amps. It could be 7 ampere, it could be 8 ampere, it could be 9 ampere, it could be 10 ampere, it could be 11 ampere. It should be more than 6.24 amps. So write any number. For example, I have written 8 amps. So it's no problem. More than 6.24 amps. Write any number. Okay. Question number C. Question number 6C part. Hair dryer. Let me increase your size. We can increase your size. No, not that much. Yeah. The hair dryer does not contain an earth wire to connect to the plug. State the feature of the hair dryer which ensures that it is safe to use without an earth wire. If an appliance is safe to use without an earth wire, The one reason can be that it has double insulation. And what the double insulation means? It means that the body of that appliance is made of plastic. So there is no chance of because the body is made of plastic, so the live wire cannot come. If the live wire comes in contact with the outer casing of the hair dryer, the live current cannot reach the the hands of the whoever person is using that, because the hair dryer's body is made of plastic, so it's not insulated. So no need of the earth wire. The answer is it has double insulation. Its body is made of plastic. I have written this answer also. Hair dryer has double insulation. Its body is made of plastic. Okay, so this was question number 6. I have tried my best to explain you the questions and their answers. Okay, we are moving to the next question. Question number it is question number 7 on your screen. Figure 7.1 shows part of a torch. The torch does not contain a battery. The torch is shaken, and this causes the magnet to move backwards and forwards through the coil. Explain why an electromotive force EMF is induced in the coil when the magnet moves. So very simple. You see, we have a torch, and what you do, you shake the torch and the magnet will move in the coil, and that will induce EMF. He says why? When you move the magnet, or when the magnet moves, its magnetic flux passing through the coil will change. Due to that changing magnetic flux passing through the coil, EMF is induced in the coil. So the answer is simple. I have written this answer. He says when magnet moves, its magnetic flux passing through the coil changes. This change in the magnetic flux induced EMF in the coil. So it's a 2-mark question. So he says next question is state one way to increase the EMF induced. There are many ways. Use a stronger magnet, increase the number of turns of the coil, and shake the magnet faster. Shake the torch faster. So write anything. The current in the coil is used to produce light from a light emitting diode. In the space below, draw the circuit symbol for an LED. So the symbol for LED, you can see here, I have shown the symbol for LED. So very simple, LED. The B second part, an LED is a more efficient source of light than a filament lamp. Explain what this statement means. You know, the LED produces less heat as compared to the filament lamp. So LED wastes less energy as compared to the filament lamp. The LED is more efficient. It means it creates more light energy with the same amount of energy used by filament lamp, but it produces more light energy. Okay, so we have question number 10. Question number 8, sorry, in front of you. Figure 8.1 shows a circuit diagram containing a 200 ohm resistor of constant resistance and a thermistor. At one temperature, the resistance of the thermistor is 1200 degrees centigrade. Calculate the potential difference across the 2000 ohm resistor at this temperature. This figure is, he wants to calculate how much is the voltage across this 2000 ohm resistor. So it's like a potential divider. If you remember the formula for the potential divider, V out is equals to R2 divided by R1 plus R2. The value of R2 is 2000 and R1 is 1200. So 2000 divided by the total resistance into the voltage of the battery. So you multiply, you get the 7.5 volt. If you know the potential divider, it's exactly potential divider. Okay, the next part is Explain why the potential difference across the 2000 ohm resistor increases when the temperature increases. You see, when the temperature increases, the resistance of the thermistor decreases. So it will take the less. Here, the potential drop will be less, but the EMF of the battery is still the same. So when it will take less potential drop, it will have to take the more potential drop. I have written its answer. When the temperature rises, the resistance of thermistor decreases. Voltage drop across thermistor decreases. Voltage of battery is still the same. So the voltage drop across fixed resistor will increase. It's a 2 marks question. Okay. So then we have B part. The circuit in figure 8.1 can be adopted to enable a lamp to switch on and off automatically. Figure 8.2 shows the circuit adopted using a relay, and the figure 8.3 shows the circuit adopted using a transistor. In both cases, the lamp switches on when the temperature of the thermistor increases. Either describe what happens inside the relay in the figure 8.2 that causes the lamp to switch on. When the temperature will rise, its resistance will decrease. So the voltage and the current here will increase. It will become strong magnet. It will attract this toggle of the relay. It will close, and the circuit through this lamp will be completed. This lamp will be switched on. When the thermistor temperature rises, its resistance decreases. The amount of current coming here will increase. A small amount of current will be introduced into the transistor, the base of the transistor. When a small amount of current is introduced into the base of the transistor, the current in the collector starts flowing and the lamp will switch on. These are the two questions. I have written answer for both of them. He says, let me reduce the size a little bit. Yeah. When temperature, for the first portion, when temperature increases, resistance of thermistor decreases and current through thermistor and relay coil increases, and relay becomes strong enough magnet to attract toggle of relay switch and lamp becomes on. Or well, the answer for the or is due to rise in temperature, resistance of thermistor decreases and amount of current increases. A small amount of current is introduced into the base of transistor. This allows large current to flow through collector and lamp becomes on. So this was question number 8. I hope that I have tried my best to explain to you the questions and their answers, and hope you have understood it. Thank you very much, everybody, and have a good day. God bless you.